With repellents, yeah, you can install them, but it would be much easier. I will try to show repellents. Yeah, actually, if you with repellents, it's like super simple to use the packages. I'll try to log in my repellents. I think for repellents, you have the IDE for printing out the results at your right hand, and at your middle part of the page, you have like the area that you type whatever you want to type in, and on the left part, you have like several choices, selections, options, and there you can install the packages. But I'm signed into my Repeller now, so probably if I get into that quickly, I can show you about that. It might be a little bit slow. And yeah, I think still we might wait some people. So yeah, this is my Repel. Might be loading a little bit slow here today. So you have like packages here. This is packages, and you can like search for Numpy. Numpy. I have already installed Numpy here because like I have import Numpy as np and also print numpy.cosine 30. So you can search here and you can install here. But I don't know, the internet is kind of slow for me today. So it's just still loading. It's a little bit annoying. But yeah, Numpad and map pull up, that's what we are going to talk about that today. Do you need to? It's just so slow. I don't really know why. But let me check how many people have came in now. We have 30 people. So we have like 22 people now. So I think I will talk about the baking, like the very first parts first. And I think people who came in a little bit late will not miss a lot. So it should be fine. So basically, that's a slide. And today we will talk about NumPy and Matplotlib. And I think we don't really have time to get to the other, but also like for Matplotlib, if we don't have enough time, then I put on the link of a video that I pre-record about Matplotlib into the worksheet. And for installation, what you will do is open your terminal, enter your directory, and type pipe install numpy or conda install numpy into for anaconda. Here, yeah. Thank you so much. And then you will over your IDE create a new Python file, and at the top type import numpy as np. Something that sometimes you will find a little bit tricky if you use PyCharm is that you need to like install numpy for that particular package each time. So also like when you install them, make sure that you install in your package, not the other package for PyCharm. But something that is easier, like not really convenient for PyCharm, is that you can just go to Project Interpreter, and then you select your projects that you want to install a certain package, certain module, and select Setup Tools. And after that, just search at the search, like the first line at the top of that project interpreter available packages and just search Python, search pandas, search matplotlib, and there you go. You can just have that. And so yeah, I have already demonstrated that yesterday. And basically for NumPy, we'll talk about what is NumPy, why NumPy, and NumPy functions and applications. Why NumPy? It is faster than List. It actually have a number of functions, and it is like memory efficient. And also for the NumPy application, it is great with plotting matplotlib and with pandas, and also if you like do machine learning or you do generally science. For a lot of science, NumPy is just like the most useful thing because for science, linear algebra is like the most essential course, and you can do NumPy with linear algebra and just for basic calculations. And first, I'll talk about NumPy data type. NumPy has a lot of different data types, and you can check that out. Platform base is not really important. But what is more important is like int, in 8, X16, and also you have like float, different type of float. And also to like specify the type, you need d type equals to np dot blah blah blah. Remember that you need to add np if it's not like simply int. And yeah, and then I will show my IDE to show about Numpad Array. Let me turn off. Okay, so I'll show my IDE. This is my IDE. Something on the chat. Okay. So I will create a new project. First, I'll create a Python file, probably just called day5. I might need to turn off my chat because if I turn on my chat, sometimes I cannot type my IDE somehow. Wait a second, because I don't know somehow because is anyone trying to talking? Wait. Okay, my Python works now. Okay, so basically, if you have already installed, I'm going to move something because I don't know what happened, but I just can't type into the IDE with a strange sound. Okay, it's working now, I think. So first we can import NumPy as NP, and what we can do to create the NumPy array is what we can just like create an array, and it's called NumPy array, and what we can put into the array is we first need to after we put this parentheses, we must need to put this brackets. Super important. Without this, it will not working. We can put like string, or we can put int, but you cannot put int or string at the same time. So if you only put int, it will actually auto casting that into a string. But something that is worth noticing is that for NumPy array, it only takes one data type. And like list, you can put a list into the list and put integers into the list and put float into the list and string into the list at the same time. And we can print out the array, the type of the array, just to check what does it show when you try to run the program. So basically, it will print out numpy.end array, and what you can do is that you can create a list, like, and then you can actually casting that into array. So you can create array2 and numpy array. You can cast the list into array. You can check that by print out array2 to see whether it is a numpy array or not. So type okay, yeah. So it is also a numpy array. So any array just means it's n dimension array. So array can be like multiple dimensions, such as we can make the array like this, which would be a 2-dimensional array. And also we can create like 3-dimension, 4-dimension, 5th dimension. This is a 2-dimensional array, and we will get to that later. And about this is two basic method about create array. What you can also create array with some counted already in that is that you can create array with MP0, and you can specify the number of zero that you want. So for example, I want 4 0 in a same dimension. So what you will get is that we will get 0 0 0 0, but you can also get like you want the outside to have 4 of them, but like inside is like 3 of them. We can print out interpret 3 as a data type. So the problem is that we need to add another bracket. So yeah, so you will get 4 of them as the outer dimension and 3 of them in the inner dimension. You can also replace 0 with 1s. What it will give is that instead of 0 0 0, it will give all 1 in it. And also you can create an empty array. But empty array is not really empty. It will only give like random number, and those random number floats 64. And also the whether like the initial content is, it actually depends on the state of the memory. I'll check the chat again. Can this be done with any numbers? I think yes, but I think I don't. I need to check the documentation later, but yeah. I think it can do with any numbers, but yeah, I'm not really sure now. But and I will get that to you later. And then about what you can do is that you can also use a range. The range give you a array that is in certain range. So each number is an element in this array. So for example, if this is 8, we have 0 from to 7. And it is similar to range somehow because it's like a range. You can also do like 1 to 8, start from 1 and add 8. And 7 because 8 is not inclusive. And also you can have the step size, which is 2. It will give you the same as a range, or like when we get to string splicing or array splicing or like list splicing, we also have like start number is inclusive and the end number is not inclusive. And also if we have create this, what we can do is that can we do this with can we do list 1 equals to convert the array into a list? We can try that out. So we have this here. We have an array called like x equals to numpad arrange, and we can try that if we have a like we can try that and we can print out that first, like try to see whether we can print out that successfully or not. My list. We can print out successfully. As a result, when we just type the type of this my list, it will return list to us. So yes, we can. Classes list. So if we have like on this print out X, we have this array and we can reshape it. So for example, what we can do is we can do like the shape of X. We can like change this to like 2, 2, for example. So 2, 2 basically means that the outer dimension is 2 and the inner dimension is 2. And we need to print that out. So yeah, I lost this equal sign, so print out the X. So it will give us a array was like 2 outside and 2 inside. Outside is the first number and inside is the second number. And for example, we can make that clear by change this to 8, and then we will have 8 numbers. So we can change this to 4. We can see that 2 is the outer side. Outer side we have 2, and inside we have 4 of them. And instead of doing like the array dot shape equals to like parentheses and the dimension of it, we can also like do 2, 2, 2. Actually, we can see this is 3D dimension, 3-dimensional array. So this is 3-dimensional array. And what we can also do is that we can directly reshape that after numpy.range. So we can use this reshape function. So what we can do is like we can reshape that to 2, 4, and it will do the same thing as if we use an x.shape equals to parentheses 2, 4. It is the same. And also the step can be like 1 to 8, but the step can also not being a integer, it can also be a float. For example, we can write the float, we can like specify the step size as 0.2, and we can print that out. So basically it will give us like from 1 to 1.2 all the way till 7.8, because 8 is non-inclusive, so we will not print out 8. And then we can get to link space. This is another way to create an array. So we will specify the start number and the end number. So between this range, we can like, we want 5 number in this range. This is what like link space means. So we can bring this out, and it will give us 5 number in this range. We can also like change it to 8. It will give us 8 number between 10 and 20. A number between 10 and 20. And what's the different, what should be like notice that 20 is inclusive here. Unlike range, like a range, like the M number is not inclusive, but here like the M number is inclusive. So it is worth remembering. And also what we can do is that we can also check the shape of our array. So we have this like X here, we can print out the shape of X. So this is 8, and this is only of a 1 dimension, so it will only give us 8. But we can like reshape that like to 2, 4, because we have 8 elements. That what we can do, and it will print out 2, 4 as a result. And then we'll talk about the size of the array. So here we have 8 elements, and if we use X size, it should be 8, because size just means all the element, or like the sum of all the elements in this. It's not it's not dependent on the shape. No matter what the shape is, the size should be the same as long as it has same number of elements. If we change this to 10, then we will have 10 of them. And this is what we can do. Like if we change it to 12, if we reshape it to 3, 4, it will still print out like the size is 12. If we change the shape to 2, 6, it will be the same. If we change the shape just to like 12 in a same dimension, it is still 12. So that's what the size will give us. And then I will like And before talking about the operations of NumPy, I briefly talk about the difference between the NumPy and the list, mathematically or especially about the operations. So we can create a my list. We have a my list equals to 1, 2, 3, 4, 5. And if we print out my list plus 2, it will not give you anything because you cannot concatenate a list with a string with a number. It doesn't not say anything. So it says that can only concatenate list, not int. So for example, if we do this, this is working and it will add 2 at the end. So this is concatenation. But if you have an array, so basically what we can do is that we can cast this list into Numpad array, my list. And you can see that we can now add array to 2. And it's not doing concatenation. What it do is just a mathematical addition. So each element is add 2 to them. So like 1 add 2, 3, and 5 add 2, 7. And also what you can do is that what's the difference is that if you print out like my list times 2, then it is also concatenation. What it will do is that it will concatenate a list of 1, 2, 3, 4, 5 with another list of 1, 2, 3, 4, 5. So this is a result, but what you can do for array is not the same. You will also do mathematical multiplication. So each number will be multiplied by 2, 1, 2, 3, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. And then also we can like actually like divide to array, like one array divide by the other array, and it will divide element wise, but you don't have that for the list. It will basically throw an arrow. So for example, if we have total ticket price, I should drink some water before this class. I'm kind of super thirsty now. Not good. So we can have a list which is called total price. That's the total price of different person. And then we can have another list which is the number of person of each group. And we will have same number of them, and they will be corresponding with each other. So we have 6 here, and then we have 6 here. So what we can do is that we can print out the total ticket price of each group divided by the number of people in each group. So we can see the average number of the price the person in each group paid. So first, this is a list. We will try to do that, but you will see that it will print out an arrow. So unsupported operand types for divide, list, and list. But what you can do is that you can cast them into an array. Someone, what? Is anyone trying to talk? If anyone try to talk, you can talk loud or something. It's not like probably like the voice of the system is not functioning well, so probably you can also like send the message into the chat box. So we can cast those lists into a Numpad array, and we can print them out, and we will get a Numpad array which will divide the first like element wise, this number divided by this divided by this is called element wise. And also like a difference is that when you insert elements into the list, you can like insert out the first index 2 elements and it will be like put into the list. But if you insert 2 elements at the same position of an array, try to replace that, it's not going to work. So an example can be like we will have list equals to we code then Python, the J, and what we can do is that we can do like list 1 to 2 equals to anyone try to talk? So we can do that and print out the list again. So we will see that Python and day are inserted to this position, and so actually it has one more element, but if this is array, it's not going to work. So we have cast this into array, and we have array 1 to 2. Print that out. It will say that cannot copy sequence with size 2 array with the dimension 1. So basically you cannot put 2 elements into the array when it only has the 1 position. But still same as list, if it already have 2 positions and you want to replace that 2 position with 2 different elements, it will work the same. So Python data doesn't make sense because it's basically the same thing. So I'll do that again. So it's working. You can see that this is the same. And also I have said that for Numpad array, you can only put the same elements into the array, while the list, you can put like string and integer at the same time. So like this is a list, print out the list. What you will see is that you will see we code in 12. 12 is still a number, we code it string. But if you do an array, which is called we code and 12, and you can print out array, and you will see that the 12 has been casted into a string. Here's not being casted, so but sometimes it can be like if we put another like we code. Let's see that what it casted. It's not casted this time, but what you can try is that if we put a list into this array, it will throw an arrow. It will not allow you to do so. Wait, yeah, I know what's the problem with that. I hasn't made this into a Numpad array, so that's why like you can do this. So all of them as their list now. For list, you can do all of them. You can put the number was a string. It will still be a number. It will not turn into a string. We put like a list into the list was the string together in the same list. It was still working, but now we have changed this to a Numpad array, and you'll see that it has print out an arrow. So the arrow says like creating an array and the array from like nested sequence, which is a list or tuple, blah 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 blah. It just simply say like you have an arrow and you cannot do things with different. You cannot put things with like different data type, and also you can see the 12 is being casted. So I need to like add a bracket. So 12 has been casted into a string, unlike this 12 hasn't been casted, but 12 remain as an int. That's the difference between list and array. So Numpad array takes one data type only. If it contains more than one data type, it will auto cast or it will throw an arrow. And then it's about the Numpad operations. So we can do an array, which we can let it call like, we need to remember add the bracket into the parentheses all the time. 13, 14. So we have 5 elements, and we can print as like an array plus another array, and it can be the same as well. And also we can like minus one array to the other array, and it's also do element wise and mathematically. If you do lists, then it will give you nothing, because if you do, like for the same to list, because it's like the element in the first list minus the element in the second list, not numerically, but just by the elements. So it will become an empty array, but here it will give you an array of 5 zeros. So that's something that's different. Also for the multiply, I have already said that it will do that mathematically. So not like give you the concatenation of the array for 2 times. Also divide is something that is being allowed in a Numpy array but not allowed in a list. And then we can do the products of arrays. So first, we have already talked about the basic element-wise product, but what we can do is that we can also do like matrix products, and both matrix dot product and matrix cross products. So first, we can create an array, a 2D array, which contain the like so like it is 2D array with so 2 dimension. The outer side we will have like 1 2 and 3 4, and the inner side we have 1 2 for this and 3 4 for the second. And also we will create another array. We can make 2 array with both like 2 dimension and 2 by 2. So this is another 2 by 2 array. So what we can do, what we have said is that we can do the element-wise products. So just 1 multiplied by 5, 2 multiplied by 6, 3 multiplied by 7, and 4 multiplied by 8. But what we can also do is the matrix form. So the first is this is a matrix dot multiplication. That's what we will get. And what you can also do a dot product is that you can a dot b, and we know that dots for a dot product, it is the sequence is not important. You can ramp that, but for a cross product, whether put a as the outside and b inside the parentheses, or a inside and b outside, it will be different. And we can put this method here, and also we can do like numpy dot a and b. So all of them are the same. We can try to print them out. It will all give the matrix dot product. So they have the same result, but what we can also do is that we can have the cross product. So we can have like a cross b, or like b cross a, and there will be different. So cross b, b cross a, and we can print them out. No, sorry, my fault. It should be numpy dot cross ab, not a cross b or b cross a. Numpy cross ab, numpy cross ba, and add the parentheses here, delete the parentheses here. That's what we will get. But we know that for cross products, what is the first, what is second is actually really important to decide what you get. It will be not the same if you rearrange them, but for the dot product, it will be the same. And also something about linear algebra is also like you can also transpose array. Sorry, you can transpose array. So a transpose, it will give you 1 3 2 1 3 2 4. So it is originally like 1 2 3 4. That's transpose an array. And also you can do the subsetting of an array. So we can like have an array that have like both numbers that's larger than 24 and the number that is smaller than 24. So this is like what you have. And then what we can do is that we can print out whether each element is larger than 20 or smaller than 20, whether it's true or false, when like in terms of satisfy the condition number of student is larger than 20, so we can see the first is true. Now it's not defined. Wait a second, it should be A here instead of like the number of students. So A here, like the first is larger than 20 is true, the second is true, the third is false, and the fourth one is false. And also we can print out the elements which is larger than 20, or the element that's larger or like smaller than 20. So I missed the parentheses. Print out all the elements that's larger than 20. You can also do like small to than 20 or small equal to 20. You can see that all the elements printed out are smaller than 20. This is a good way to filter out the elements in the array, and we can also do array slicing. So for example, we can still do like print out 0 element. We can print out 0 to the first element. It seems to be the same, but it has a lot of differences. The first will print out the element, and the second will print out an array. And we can still do like the array, and the start is from 0 and it will end before 3. Or we can also do like the step is 2 while the entire array is being traversed, like in this way. And also here you can make the n number become really large. And also you still have like negative indexes, and you can still do the slicing of the negative indices. And what we can also do is that for the array, you have different dimensions, so you can just slice that in different dimension, get to different parts from different dimension. So what you can do is that you can print out the array. Like you can print out A, and you can print out like 1 1. 1 1 will give you like this is 1 outside and this is 1 inside, so it will give you 4. But this is also something that we can do with a list. So basically we can extract this out, and we can also print out list 1 1. It will give you the exact same thing. But what you can also do with the array, you can actually put them put this two, put slicing the row and slicing the column together. So, but if you put the list, you cannot do like row, comma, column. It will throw an arrow instead. So that's the difference. And also, if you have like a lot of numbers, what you can do is that you can like slice still with like the star numbers, the n number, and also the step for like each of them. So here we have like this array. We have a 2D array which has the shape of 4 and you can like slice a row like any other slicing, and you can slice a column just like any other slicing. You connect them by a comma instead of doing this. You can also do this. This is still right, but this is not mandatory. And also, since you can do this, what you can also do is that if you just want to take all rows, you can do an empty like just nothing before this comma. And but what you need to do is that you still need to add like the start number and the end number. You cannot just do this. This is not like valid. You can do this. You can also do this. this 2 is both working. That's also slicing in different dimension and the special part of the array slicing. And also you can still modify the array. You can like modify the array like as a position of 1 3 and like 1 1 3, so this is 1 and 0 1 2 3. So you can make that equals to 9, although it equals to 8 now. Print out this this array. You will see that here's 9 now. You can also like 3, so you can do like from 1 to 3, from 1, so like here 1 is 1, so from 1 to 3, and 3 is not inclusive, so 6 and 7, we can change that like to 7 and 8, and we can see like it's 7 and 8 now, so this is string modification. And what we'll get to next is that we will get to the other like math function in NumPy. So what we have is that we have NumPy square. So basically we can like put like the square root of 2 here. It will print out the square root of 2. We can do like NumPy dot reciprocal. It will give you the reciprocal. And for example, 1 over 2, it will give you 2 for the reciprocal. And you can like do numpy.log. And this is what it will print out. And you can also do numpy.py. Also, you can do math.py, something I hasn't mentioned before. Like, we have this like math function that's built in. Do we have that now? Possibly we don't have that. Possibly not for Python. Oh, we need to import math. Math is a built-in, also another like built-in package of Python, just like random. That built-in means that you don't need to download them. You don't need to but you still need to import them. So I think in this way we can do like math.py. Yeah, we can do that. It is the same as if we do like numpy.py. But if we import NumPy, there's no way to import math because NumPy already like it includes the math packages in it. And what we can also do is that I will leave it here. So what you can also do is that we can do like sine or cosine or like tangent of the angle with NumPy. So NumPy is like really important in math calculations. NumPy.tangent. Also, we can do like NumPy.arcsine. NumPy.arccosine. The arctangent. So we can print them out. It'll give you the values. And remember that if you do numpy.sine, then it would take in, you can see like what it take in. So what we can do if we don't love the take in, what we can do is that we can do like numpy.radian. So you can get the result, and here all of it takes the degree. So if you want to let it take degree instead, you can just convert radian into the degree with numpy.degree. So like numpy.degree, numpy.pi, for example, it will give you 180, and then you can like put it here. Also pi it's not fine, but you can tell like pi over 4. And let's check it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it will give you the results. And then we can also do statistics with NumPy. So what we can do is that we can like just create a random array. Probably something that we can calculate easily. So we have an array here, and what we can do is that we can calculate the mean of this numpy.array, numpy.mp.array, because I've already imported as an mp. So we can calculate the mean of it. We can calculate the standard deviation of it. We can calculate, like, we can find the maximum number in this array, and also we can find like the minimum value in this array. So minimum array. So yeah, we can see that's the sum of them. I think we can also do sum, but I'm not really sure about it. Let's check. Can we do sum? Yeah, I think we can do sum. So the sum of the array is 20, and then 20 divided by 4, so the mean should be 5. And we have the standard deviation, and then we have the max number, which is 7, and the minimum, which is 2 here. So that's how can we do the statistics with NumPy. NumPy has really a lot of functions, so you can search like the documentation of NumPy to see what does it have. Like radians, we have talked about that, convert the degree to radian, reciprocal, convert like 1/2 to 2, 2 to 1/2, zeros, creates the array with all zeros, cosines, cosine of sine, pi is just a constant, and also the minimum value. That's like what we have already used. And flip is you can flip an array, so we can try that out. So print flip array. This is not a 2D array, so this is not working with. So what we can do is that we can change it to a 2D array. Check that again to see what that flip is. So you can see that it should be, we will print out the origin value. If we print out origin value 572 and 6, then what it will give you is that it will give you like 7562. So it's being like reverse according to a vertical axis. This is what it's doing. And also you have something called flip UD. And the flip UD would not flip it like according to the vertical axis, but would flip it according to a horizontal axis. So you can see 26 becomes the upper part and 57 becomes the lower part. It just have a lot of different functions, so you can look at the documentation and explore by yourself. But then we will briefly talk about matplotlib. So what we can do is that you can import matplotlib.py.plot, matplotlib.py.plot as plt. And then I think because we don't have a lot of time, I will go to my document to show you. So here we have this plot. So first if you want like plot something, then you need to have the x value, you need to have the y value, and then so this is like a complex version. So let me get to a like simple version. So plt 111, and then copy this. So from matplotlib, import plot as plt, and then you have like the x value. For example, this is like the age of a student, and that's like the number of rounds the person have each age. It should have same number of elements because it should be corresponding to each other. And then what we do is that we can do plt.plot plt.plot, and then we need the x value, which is ages, and the y value, which is friend number. And then we can do pl.show, and we can run this. And it will take a second to run that, and I will share my desktop instead, because in this way you can see what I'm doing. So I'll wait a second, just stop sharing somehow. Can you see my desktop now? I think you can see that, right? Yeah, I will share the code. I will share the code later. I haven't put that out yet, so just also like, so .py.show, this is the image that show, but it does not have a title, it does not have the label. So so the access pld.plot, we can pld.s label, so we can label it as like the age, or like the ages with plt.y label, like the number of friends, and also we can add and add a title to it. Title, so the title could call like number of friends by age. So we can plot that again. So now we have the title, we have the X label, and we have the Y label. But what we can also do is that we can like also add a grid to it, plt.grid, and print that out. So what it will give us is that, wait a second, where is it? So yeah, it gives the grid to us. And also what we can do is that we can do plt save fig. So plt save fig, it will save the like just call Michelle. So it will save the graph in under the name Michelle. So yeah, and another way that you can save on, so I can like try to find that file, but I think it's super messy, so probably okay, so super, I think my laptop is super messy, so I will not try to find it now. But also what you can do is that you can save the fig in this way. So here we have a save sign, so you can like name that and save that in the desktop. But if you save in this way, you need to remember that it will save like everything here. If you like zoom in, then it will not like save everything, it will just save this part, so this is not complete. So you need to readjust it into a proper position before you save in this way, if you open the window and save that. And also like here we can add another plot to it. So if we have like another friend number here, and what we can also do is that because we have two number, like if you just plot that, wait a second, I should add another plot. So it would be a little bit confusing if we have two lines at the same time. Like this, you can not really distinguish which line belong to which. So what you can do is that you can label them. So like you can label the first one like A, and you can label the second as B, and you can like plt plot the label, plt.label, and then plot that. Take a second. Wait a sec. Not label. My fault. It should be legend. So plt.legend and parentheses. So you will see that the first line, like the line belong to A will have A here. The line belong to B will have B here. And also like what we can do is that we probably cannot do like the label here, but we can like remember the sequence that the first belong to A and the second belong to B. So what we can do is that we can put like A here and we can put B here, but this is not the recommended way, because if you have a lot of value, although you give it the same thing, you cannot like remember the sequence of like what did you pull the first, pull the second, so it will be really confusing. And what we can do is that we can also like change the style, but before changing the style, what we will do is that we will change the marker color and label. So more details about marker color and label, it's in like my PowerPoint. Uh, so get to this part. So format string, marker line, and color. So that's like the different marker, different symbol for the marker. It's so small now, probably you can't see that, but you can check the PDF. Different line styles and different colors. So what I would do is that like I would just copy one of them to this one. So because it can take time typing. So basically the marker equals to like V, or like the marker you can equals to like dot, the marker you can equals to like this. So you can like try to print that out. So this means small triangle. You can see the triangle here. And also like, well, we can also like here should be A because that belongs to person A. Here should be like B. And marker are also like we can do line styles. So line styles, line style. And the line style we can check here. So what line style do we have? Line styles. So we can do like the solid line style, the solid like this, solid line. The solid line is a default, so probably will not do solid. We can do like the like dashed line was like this. It says that, wait a second, it's not supported. The supported value oh yeah, I just didn't press the shift button. So this is a line style. But it's also like true, like if you don't remember like types around one, and what it will do is that it will give you the hint of like what can type, because it's true that it's like super hard to remember everything. So you can see this as some that we got. So like we can um just paste them here, and then we can see that we can try the different version out. So we can try like dash dots. So we have the dash dots, and we can also do like try this. You can also try different color, and about different color, I put them into the PowerPoint. And also what we can get is that we can get to style. So we can print out the style available with prints on plt.style.available, and we will see that we have like all the styles here, so you can choose any of them. So we have VMH, that's the one that I choose here. So plt.style.use, this is VMH. We can do like dark backgrounds. This one is like a bit more dramatic. Some has a red in itself, in its style. Wait a second, dark background, I believe. I can print out the style again to check that. So dark background, yeah, it should be dark background instead of dark ground. So dark background, and we will see that it's dark and now. And also what we also have is that there's something called plt.xkcd. So it's Xkcd Comics. So it will be comic-like, which is really cute in a way. So like this, but it's not clear, and probably we should delete dark background while using it. So this is comic-like. It does not have the grid. Even we have specified the grid here because like that's its nature. that is all the different styles here. You can also check that out. And the second is about the bar chart. We are also running out of time, so I'll just show you. So for bar chart, you still need like the X value in a list and the Y value in a list. And then you need to like write. So like indices is what I would talk about. Like if you use that was like a side by side bar, you don't need that if you don't do that. If you only need a like so we can like try to comment that out. So comment this out, and we will do like just plt dot bar, and we'll just do like round number. So we only have a bar now. Let's see that. Yeah. So the words, they will not be used, so they will be fine. We're not using them. Bob missed the height. Bob missed the height. So what we can do, we can it does not need a height if we only have one value. So what should I comment it out? We have the x indices here. We can like do a words here. So that's like a function of it. It should not ask you for the height, but we can also check that out. So height, like height equals to 1. So let's plot that out. So this is basically what it looks like when the words is just so small. So and when the height is like 1, we can like try out different values. So that's super high. Height equals to 2. It looks like this. That's like what it look like. The width equals to 2. You check is that better. So if the width is 2, it make more sense. So basically, like the width what you need, but it's not like 100% necessary also. So this is when you want to draw a side-by-side bar. So why you need like indices and indexes is that you want the bar move a little bit away from each other, so I can comment it out. But if I comment like this out and change on delete, like I can delete the x indices, probably delete the words. If I delete the words, they will be overlapped with each other. So they overlap with each other and you cannot see which is which. But also like you can add a base. I think you can add a bottom. Yeah, you can add a bottom. So the bottom of this should be equals to from number. So then from number 2 will be above from number. This is segmented bar chart. So you get a segmented bar chart here. But if you forgot to add this is not making sense because this is not the segmented bar chart. This is just the B chart is like covering up the area of the A chart. It doesn't make sense here. So this is not a segmented bar chart, but if you want a segmented bar chart, make the chart that you want be higher with the bottom function. But if you want to make a side-by-side chart, you need to specify the width, and you can add the width into the x indices, and then it will give you the bar chart. And I will also like show you this is a histogram. So for histogram, you have like all the random numbers, and the random numbers can fall in different categories, can fall in different range of numbers. For example, we have the bin of 10, 20, 30, and 14. So they are different range that contains like this number, classify those number, and will tell you like so like about like 9 people fall in this range and about like 5 people fall in this range. This is a histogram. The difference is that For the plot chart is plt.plot, and for histogram is plt.hist, and you can add edge color. But for the plot, you don't have edge color. For bar chart, you also have edge color. You also have the color for bar chart or plot chart or like scatter plot. Also, you have the bins. The bins, the default value of the bins is 5. It will give you 5 bins. So bins can equals to a list, but bins at the same time can equals to the number. So 5, it will separate into 5 bins, but you can also specify the range. It's all the same. It's plt.hist here. And also what we have is that we have the scatter plot. So I can also run the scatter plot to let you see this. But if you have any other things to do, just feel free to leave. And also I will post a video about Matplotlib into the worksheets. So we are running this. So for the scatter plots, it has much more attributes, and scatter plots use plt.scatter. So let me find plt.scatter, and it takes the x value and the y value. So like the x value here is the days, day number like 1, 2, 3, 4, 5, and that's like the number of students in this camp, like in the camp every day. So like, and then this like we have the colors. So colors is like for example here is the number of hours, like the average number the students in each camp use. So here if the color has like higher number, and then it will give you a bar with like more yellowish color, like it will give you a circle with yellowish color because we have this bar demonstrating or like showing the frequency. And also if it close to 1, for example, like here is 1, and like it's like then its corresponding point we have like a darker color. And also you can like specify the size of the color. So all of them have same number of elements, same number of elements, same number of elements, same number of elements, and same number of elements, and each of them are corresponding with each other. So the size, you can see that the this 571, the day 5, and which is 7 number of students, and the size is this 290. It's not so big, so it's not so big here. And you can see the color of like this one is about 7, so this is about 7, is corresponding with this bar chart, with this scatter, like with this bar. And for the scatter plot, you need x and y, you need the size, and but it's not something that you must need it. You can like omit this part. You can omit the color attribute. It will give you the default color. And C map is a color map, which also I have shown here. So this is like the color map, which is basically the colorful bar here on this graph is a color map. You have different color map, like what I have like put here. We have alpha, which is the transparency. You have the line width. So it's the width of the like this like black line or like colorful line if you change to other color, but this is the line width. And edge color is black, so edge line width is the line of the like the width of the edge. And you have different C maps, rainbow terrain, all the really colorful thing. And also like if you want to plot the color bar, you need to add like plt.colorbar, and that's the way that you can show the color bar, but only in this way you can comment this out. It will be confusing why we have different color. So like we need also like commented this out. So now we don't have the color bar, but we still have the color, so it can be confusing. And also if we don't use set label, then we will have the color bar, but we don't know what the color bar means. Whether the color bar means the average hour of students spending in coding or average number of students spending in doing other things. We don't know about that. We don't add like C bar dot set label. And also we have pie chart. So pie chart is basically pl.py, plt.py. So I can run this. So this is a version. This is not a beautiful version. I think I have do a much beautiful one is this one. This one has color which hasn't been like too small deliberately, which look nicer. So basically you can put the slice. So slice is like the frequency of each part. And if the frequency is high, then you will have like large shell. And the frequency can be the percentage, but it also can be random numbers. So if you add all of them together, it will be like larger than 100 here. That's all you can do. And the label, you can label each of them. So the pie chart has an attribute called label, and it can take a list. So it's basically the list here. It can take a list of colors. So basically it's here, and it can take the how far it explodes. It can take a list. So if it has like 0.1 explode, it's like those that explode out a bit. You can put like larger number, it would be much outer, but if it's 0, then it's like stick into the middle part. And also the shadow equals to true. Now shadow equals to true. You can see the shadow here. And the start angle basically means the first value, which is like tag for good. Tag for good, it's now starts at tag for good 90 degrees. So the default degree is here. The first should be like here if the start angle equals to 0, but now start angle equals to 90, so it starts from here. If it starts from like 217, then the ratio will be like here instead of like now here 90 degree. And also the octo PCT. So basically that means how are you going to format the percentage. So basically now it's in 1 digit, but you can add another one. Then we will have like 4.44, for example. So now like it has like a lot of different digits. It's a little bit confusing if you add too much. And also the edge color can equal to black. So that's the property of the edge, can specify the edge color, and also like the line width, just like what I've say in for the bar charts or like for the other chart or for the scatter plot. And also tile layouts, it's usually not different on some laptop. So you can also comment that out. You can also add that. You can try that yourself. So that's basically about the useful matplotlib function. And you can feel free to ask questions. Could you send all the codes? Yeah, I can send all the codes. I will definitely send them. I will put them into the PowerPoint, or I will like put a link into the worksheets today. And also I will put a video just explaining them again about the matplotlib, because we currently running out of time talking to them. And I think a lot of people like, some people have other things to do, so they left the meeting in advance. So I will also like put that video also for them. So do you have any questions? So just feel free to like ask the questions. You can ask the question, or you can feel free to leave. Color has different color. So to show like, so to use different color, can use a hex number. If you put the hex number, then you would put what you would do is let me find if I have any example that I use hex color that it uses. So this is an example of using hex color. And this is like the most most default color, and you can write blue, B instead of blue because it's the most uncommon one. You can write R instead of red, and I think also G instead of green. If it's like white instead of yellow, I'm not really sure about that, but you can check that out. Do anyone have any questions? You can feel free to leave if you don't have questions. But also you can put the questions into the worksheet. Thank you a lot. Thank you for being here. Thank you. Thank you.